So students, today we have this question of permutation and combination. The question is number of triangles that can be formed with the n vertices of a n-sided polygon such that the triangle, it has no side common with the polygon, such that triangle has no side common with the polygon. See, how I tried this question or how I solved this question. So it's just a minute, yeah. So of course I can't draw n-sided polygon here. But if I draw like few a polygon, okay, not a complete polygon. Now see what I said. Let's say we have to select 3 vertices. Of course, to get a triangle, how many vertices we need? We need 3 vertices out of n. But the triangle has to be such that it has no side of a polygon as its side. Okay. So I said, okay, randomly let us select 3 points. Now if I say that between these 2 points there's a gap of x1 vertices, between these 2 points there's a gap of x2 vertices, between these 2 points there's a gap of x3 vertices. Now what should be the sum of x1, x2, x3? So the sum of x1, x2 and x3 should be how much? N minus 3. Okay, now what? Now if we we don't want the 2 adjacent or consecutive vertices to be selected, because if 2 consecutive vertex you select, you will be selecting actually a side of the polygon. Okay, so you can't select a vertex which is just adjacent to this one. What does that mean? That means these x1, x2 and x3 should be greater than equal to 1. That means the x1, okay, there has to be a gap of at least 1 vertex between these 2 vertices which we have selected. Okay, so what does that mean? So that means, see, actually I want to discuss one formula also for the non-negative integral solution. So what will I say? Okay, I will say let x1 be 1 plus p, x2 be 1 plus q, x3 be 1 plus r. Substitute this value here, where p, q, r are greater than equal to 0. Since p, q, r are all non-negative, hence x1, x2, x3 will be all greater than or equal to 1. Bachcho. Now put these values of x1, x2, x3 in the equation. So you will get 1 plus p plus 1 plus q plus 1 plus r is equal to n minus 3. Hence p plus q plus r is equal to n minus 6 rather. So it will be n minus 6 here. Now what do we need here? So for this equation, number of non-negative integral solution. So non-negative integral solution means the whole number solution. That means p, q, r can be whole numbers. Okay, non-negative integral solutions will give us the possible ways of selecting x1, x2 or x2, or the possible ways of selecting those 3 vertices. Bacho. Okay, now so how do we get it? Yeah, that's what actually that's one more aspect because of which I am discussing this question. So if you have any such equation where r variables add up to give n, and we need its number of non-negative integral solutions. We need number of non-negative integral solutions. So there's a direct formula, I'm not going to derive it here. Okay, and that is n plus r minus 1 c r minus 1. What is r here? R means number of variable. So r is 3 here. Of course, this r is different than this r. Okay, so there are 3 variables and n is of course 6. So therefore its number of integral solutions are 6 plus 3 minus 1, rather it's n minus 6. I am really sorry, it's not 6 here, it's n minus, I just saw this. Okay, it's n minus 6 plus 3 minus 1 c2. So what is it? So it's n minus, how much is it? 7, no? 4 c2. Okay, so that gives us the number of ways of selecting such 3 points or vertices of an n-sided polygon, such that no 2 adjacent vertices are selected. But then see, when you draw a polygon of course every vertex has a unique position. So of course you have to start it. It seems to be a cyclic thing. It's a closed figure. Okay. So in how many ways you can select the first vertex? So first vertex can be selected in n ways. Yes or no? You can select any vertex out of n. So the first vertex can be selected in n ways. Then second, between first and second you have x1 gaps, x2 gaps and x3 gaps. So number of ways of selecting the other two are this many. So total number of ways of selecting such three vertices. So such three vertices, how many are they? Are n into, because for every n ways you have n minus 4 C2 ways. Okay, so how many are they? N into n minus 4 into n minus 5 by 2 factorial. Okay, or by 2. Now, does this gives us all possible triangle? See, there are so many repetitions. How? See, what will happen is, when you select this vertex, okay, you select this as the second vertex, join it, this as the third vertex here. Similarly, out of n ways, it's possible that you might be selecting this. And after a gap of x1, you select this, gap of x2, you select this, and there's a gap of x3 here. Likewise, out of n ways, it might happen that you select this. That means a triangle, the same triangle can be obtained in 3 different ways. I think I'm clear. The same triangle can be obtained in 3 different ways. Okay, because you can start your first vertex in n ways are there to choose the first vertex. So first vertex is this, then also you get a triangle. If first vertex happen to be this, then also you will get this triangle. If first vertex happen to be this, then also you will get the same triangle. So every triangle is being repeated in 3 ways, or so the number of triangles. So therefore, number of triangles are 1 by 3 into n minus 4 into n minus 5 by 2 bachon. So that should be the number of ways of a number of triangles which can be formed using 3 vertices of a n-sided polygon, such that no side of a triangle is the side of the polygon bachon.